Hello students, welcome to our channel. In this channel we will be discussing physics of NEET and JEE mains. Okay, so 11th physics and 12th physics together we will be discussing 200 important topics for the NEET and JEE. Okay, so if you see the 11th physics, there are approximately 15 chapters, and also 12th physics there will be again 15 chapters. Okay, so total 30 chapters. From overall 30 chapters we will be having 200 important topics. Those 200 important topics, if you master, if you know how to solve the problems, definitely you will be getting minimum 140 marks in the NEET exam and very good rank in the JEE also. Let us consider condition for total internal reflection and also grazing emergence in case of prism. I hope you have remembered the previous class, okay, and that is regarding the prism that I have already given this derivation. If this is the angle of prism A and here the incident ray will be incidenting here, and this is a normal drawn at the point of incidence. Definitely actual path of the light ray is this, it will deviate towards the normal because going from rarer to denser, and this is the angle of incidence I, and this is the angle of refraction R1. Actual path from here it is this way, but the normal drawn at the point of incidence maybe this one, and they will intersect here, and from the actual path it should deviate away because going from denser to rarer. Okay, so it will deviate away, so that this is going to be angle of emergence, and this is the angle of incidence R2 I have given, and also told you that R1 plus R2 equals to A. Okay, and with this we are going to see the condition for total internal reflection, or condition for this one, this is grazing emergence. Okay, if it is grazing emergence, okay, that is what E is going to be 90 degrees. Okay, if grazing, then angle of emergence is 90 degrees. If angle of emergence is 90 degrees, then corresponding R2 is going to be critical angle. Okay, then we can say R2 equals to critical angle. Okay, if R2 is critical angle, from the formula R1 plus R2 equals to A, we can say R1 equals to A minus C. Okay, and we can apply Snell law from here, medium to prism, that I already applied. Okay, we had the formula here, that sin I equals to mu sin R1, and I can substitute here sin I equals to mu sin A minus C. Okay, and I can rewrite this, or I can understand clearly here. You can see this equation and understand. Suppose angle of incidence increased, then angle of refraction also will be increased. Okay, then what would happen to the R2? It will decrease. Okay, general formula from here. Okay, so we can write here, if I is increased, that is angle of incidence is increased, then R1 will increase, that will result the R2 to decrease. Okay, if R2 is decreased less than critical angle, then it will not be total internal reflected, it will be refracted. Okay, so whether the emergent ray will be there or not, that is decided by the angle of incidence only. Okay, so here the three possibilities we have to understand. Depending on the value of angle of incidence, we will have the three cases, that is refraction, the ray will emerge out. Okay, this we can write it as emerging. Okay, and grazing, the second case is grazing, third case is total internal reflection. Total internal reflection. So condition for this, if angle of incidence at AB face is greater than the sine inverse mu sin A minus C, then the situation will be like this. This is a prism, angle of prism A, B, C, and this is going to be the incident ray. Actual path of the incident ray is this, it will be refracted like this. Okay, but angle of incidence here is not, it is not going to be equals to C, that is R2 will be less than C, happens in this case, so that it will become refracted. That is what emergent, that is when the angle of incidence at the AB face is this one, is greater than sine inverse of mu sine A minus C. Okay, in that case R2 will become less than critical angle, so that the emergent ray will be there in the system. Grazing, when the angle of incidence is exactly equals to sine inverse of mu sine A minus C, right? In this case, what happens, R2 will become equals to C. If R2 is C, then the AC surface, it will graze the AC, okay? The refracted ray just grazing the AC surface, okay? This is angle of prism A. Actual path of the prism is this, then it is incident at an angle C, so that this will graze the AC surface. Okay, let me draw properly. Yeah, so it will graze the surface, so that the angle of refraction is 90 degrees. Angle of emergence is 90 degrees. Okay, and this R2 equals to C. This is a case 2. Case 3, total internal reflection. Okay, so for this the condition is angle of incidence at AB surface. This is AB. At AB, the angle of incidence I, this I should be less than, sine inverse of mu sine A minus C. If this is less than sine inverse of mu sine A minus C, corresponding R2 will become greater than C. If R2 is greater than C here, then what would happen? It will actually undergo the total internal reflection. So it will go TIR. Okay, so I can draw the diagram here. Actual path is this, sorry. Okay, so this is a refracted ray. Here is a normal drawn at the point of incidence. This angle is greater than critical angle R2, which is greater than C. Then it will have total internal reflection this way. Okay, so these are the 3 cases. Remember the condition that I, that is sine inverse of mu sine A minus C. Then you have to take the 3 possibilities. If I is greater than sine inverse of mu sine A minus C, it will have emergence. If I is equals to sine inverse of mu sine A minus C, it will have grazing. If it is less than that, then it will have total internal reflection. Okay, so let us discuss the next condition, that is the minimum deviation condition. In this case, the light ray will be incidenting on the prism at certain angle, so that it will have the minimum deviation for that incidence. Okay, so the deviation formula from the formulas we have written already in the previous class, that deviation delta equals to, it is I plus E minus A. Okay, where E we can write, from the formula sin E equals to mu sine R2, and we can rewrite this E equals to, sine inverse of mu sine R2. Okay, and with this we can find the deviation, the delta, as a function of this one. Okay, so the deviation equals to I plus sine inverse of mu sine R2 minus A. Okay, and the graph of this one, if you plot the graph, the deviation versus angle of incidence, the graph is going to be this one. Okay, so the angle of incidence I, the deviation is delta, and the graph is going to be like this, and it will suggest us, it will be giving us the information, that is, first, as the angle of incidence increase, the deviation will decrease. Okay, and it will become minimum at a certain angle of incidence, say this is I. Okay, the minimum angle of deviation, we call it as capital D. Okay, and beyond this angle of incidence, if you further increase the I value, then angle of deviation angle will be further increased. Okay, and from this graph we can also confirm that deviation, say delta, will be possible for the 2 different angles I1 and I2. For the 2 different angle of incidences I1 and I2, we can have the same deviation. Suppose this I1 is 30 degrees, I2 is 70 degrees. Then for 30 degrees angle of incidence and 70 degrees angle of incidence, the deviation will be same. Okay, so that is what we can understand here. And what are the keywords that we can have here? Okay, let me keep the heading here. That is for minimum deviation. Minimum deviation. Okay, and the keywords here they will mention the incident ray. If I draw the diagram of the system, this is the prism, angle of prism. Okay, incident ray is this. Okay, and refracted ray will be this, and emergent ray will be this one. And here I have already given the symbols like letters for this. This is P, Q, R, and this is S. The PQ is incident ray, QR is a refracted ray, RS is going to be, emergent ray. Okay, so here in this case, that is what in minimum deviation condition, one condition is there. Okay, the QR, that is refracted ray, is going to be parallel to the BC. Okay, that is what the base of the prism, and the refracted ray QR are parallel. Okay, so QR is parallel to BC. This is one condition we can have. Okay, and next thing, the angle of incidence and angle of emergence are equal. That is what, at what angle it is incidenting, with the same angle it will emerge out. Okay, that is second case, second condition we can have. And we can have one more, the angle of refraction and angle of incidence inside the prism. Here R1 and R2 we have discussed already. So R1 equals to R2. And from this we can say 2 times R1 equals to 2 times R2, which is equals to capital A. Or we can have that R1 equals to R2 equals to half of the A. Okay, so there are 3 conditions I have told you. First one is QR is parallel to BC, that is a refracted ray is parallel to base of the prism. Second one, angle of incidence equals to angle of emergence. Third, angle of refraction inside the prism equals to angle of incidence inside the prism. From there we can say R1 equals to R2 equals to A by 2. Okay, and the last condition will be there. That's a formula that I am going to write here. Okay, if you apply these conditions in the equations, the first 4 equations, okay, so there mu equals to, you will get a formula that is sine of A plus the minimum deviation divided by 2 whole divided by sine A by 2. So this is very important formula I can say, because based on this there will be many problems they can ask. Okay, many cases they will ask. Okay, so mu equal to sine A plus D by 2 by sine A by 2. Okay, so what are the conditions at minimum deviation? Let me tell you one more time. The first condition is the QR is parallel to the base. Second one is angle of incidence is equals to angle of emergence. Third, you can take R1 equals to R2, or it is equals to half of the angle of prism. And the fourth one is a formula that is mu equals to sine A plus D by 2 by sine A by 2. Okay.